Yo, yo, yo! Welcome to my channel. This video is about a tricky question. This question has actually been posed to me by one of my students. As she going through the maths in class, the teacher, her teacher at her school has actually asked them to do this particular modeling questions. And I think the teacher went through the question with them, at school. But like most of the not so good teachers, no offense to the good ones, but there are some very average one out there. So just like those very average one, the teacher didn't really go through clearly enough, and he deliberately leave out the last answer. And no, I can understand what he trying to do. He might want to get the student to actually try to go at home, have a go at home. So once my student told me this, and I was like, interesting. And her teacher said that this is A-level question, and I was like, okay, then maybe I should make a video about this and show everybody. And sharing is caring, right? Okay, so without further ado, let's start. Okay, so it's a modeling question. The voltage of an ordinary power supply is given by V equal to V0 sin WT. Now that's not very, I don't think that's a W. I think that's a particular Greek symbol. I don't know at this, couldn't remember it right now. If you know, please leave it a comment. Where V0 is equal to 340 volts, T is in seconds, and something that looks like W is equal to 100 pi hertz. The instantaneous power generated by a resistance of R, which is omega, ohms, is given by V squared over R. Since the voltage varies, the power of an appliance is normally stated as the average power over 1 second. Okay, so that's the model. All right, let's have a look at the questions. No, actually, let's break it down as well. Let's break it down first. So we got a voltage equation at the beginning, right? We got a voltage equation. V0 is 340, T is in seconds, and that W symbol is 100 pi. So the only thing we don't know is T, right? So T is the variable in that case, and V is the actual voltage being output. And it says here that I'll use a different pen. It says the instantaneous power generated by a resistance of R ohms, which is a resistance, is given by that V squared over R. So we can right now put a equation, put a right little equation on the side. V squared over R is somehow equal to power, right? The instantaneous power, right? Okay, and then it says, since the voltage varies, the power of an appliance is normally stated as the average power over 1 second. All right, over 1 second. All right, so let's jot down all those important bit. Okay. Right, let's have a look at the first question. Find an expression for the power in terms of T. All right. Find an expression for the power. So we're looking for power, which is this, right? And express it in terms of T. Okay, so we want power on one side of the equal sign and T as on the other equal sign, the other side of the equal sign. All right, so we got this particular equation here, V squared over R is equal to power, and we know what V is. All right, well, let's just mix them in. All right. Okay, so for question A, so V is equal to V0 sin WT, right? That's the equation. Yep. And the other bit is V squared over R is equal to power. Okay, so well, I will sub the v into this v squared over r. All right, so this is literally just this v0 sine wt all square over r is equal to power. Right? Yeah. Okay. So let's expand the top side, the top bit. Right. So the square would distribute into both of them. So now we know V0 is equal to 340 and W is equal to 100 pi. Right? So we actually get 340 square multiplied by, now because there's between is a multiply sign, by whatever this square. Right? All over R is equal to power. Okay, so if you want, we can calculate what 340 square is right now. 340 square is, woohoo, big number, is 115,600. All right, and this one stay the same. All right, over R equal power. Right, and I think that's it. That's all we can do. Right, so did we find an expression for the power in terms of t? We got the power on one side, right, and we got the t on the other side. Cool, right? All right, we got the first question done. Yeah, let's look at the second one. Use the identity sine square x is equal to half bracket 1 minus cos 2x to change the expression to one that may be integrated. Right, so this interesting thing here is what we call, it's one of the trig identity. It's called what we call a half angle rule, half angle identity. All right, so this bit actually allows you to convert a sine x squared. Now this expression is this expression is the same as this. Okay, it's the same expression. It's just a different expression. Same thing. All right, so we allowed this half angle rules allowed us to convert a square of a sine into literally get rid of the square, right, into something else with cos, so we can integrate it. All right, and this particular rule is used in some advanced integration method. All right, but we will talk about that later on, another time. Okay, I'm sorry, I just got excited there. All right, so we have to use that. Okay, so B. All right, given sine square x or sine x square is equal to half bracket 1 minus cos 2x. Right? So we can convert our previously constructed power equation into something that we can integrate. All right. So let's write down the equation from before. Over R equal power. Right. So all right, so let's observe here, right? So to remove the square, we convert to half bracket 1 minus cos. So if we're going from sine, we could become cos 2x. Now the relationship between it is this is x here, this is 2x here, right? Obviously you get twice of what x was before. Now because there was a 1 here, if you didn't realize, it becomes 2. All right, so applying that into our formula will become bracket 1 minus cos, right? Now, what we had here was 100 pi. Now, the t is just the x, okay? The t is the variable in this particular scenario. So the t is just an x. So whatever in front of t, or whatever in front of x, will be doubled. So we just go 200 pi t, close bracket, all over r, equal to power. Right? Now we can expand some of the brackets to make life easier. So this would become, so let's distribute the half into all of them, right? So it becomes half, one, or half times 1 is half, minus all this bit on 2, right? It's all over r. To the power, right? And now we can further distribute this into them. This is 115,600 into both of them, right? Because it's a multiplication. So we're having that. So 115,600 divided by 2. So you get 57800 minus, literally, 57800 cos 200 pi t. All right, I should actually bracket this, yeah, because some genius. I'll show you what I mean later on. Okay, so some of the genius that I found, that I have come across in my in my pursuit of mathematical journey. In my pursuit of mathematical journey, I've met some genius who decided they can do this, and I was stunned. I was stunned. Okay, the answer is you can't, because that's inside the cosine. You can't do that. Okay, you can do it to this one. You can do it to this particular number when it multiplies it, but you can't do it to inside the cosine bracket. All right. Whew. All right. It's all over r equal to power. Now this is something that we can integrate. Right. Before we got a square, we got a sine square, sine bracket whatever inside the bracket square. So we can't do that. We can't integrate that normally. But now we only got cos, and there's no square, so we can integrate this. Cool. So let's say use the identity, okay, to change. Yep, we did that. So number C, find the integral of v squared over r for the period 0 second to 1 second. Okay, so this is definite integral, right? So from 0 seconds to 1 second. To give an expression for the wattage of the appliance. Oh, wattage, which is watt, which is power, right? Okay, so we have to find the integral of v squared over r. All right, now don't forget, this is already v squared over r. What we got here is already v squared over r, okay? This is already v squared over r. Okay, so question C, is it? Yeah, question C. Question C. Whew. So we are integrating, good, from 0 to 1, right? This particular function. Oh no. Let's to be sure. Alright, let's to be sure. What is my method? My method always I would do top minus bottom. Integrating with respect to, what are we integrating with respect to? Right, it's t, right? So we are dt. There's no x in here, so you can't integrate with respect to x. Okay, be careful. Right, I still would like to do the top minus bottom because I don't know which function. I don't know which will our power function be on the top or the x-axis be on the top. We don't know. So, yep. So let's go to decimals and graph it. All right. Okay, sad news. I can't get the function to work on decimals because we've got an r. We've got an unknown here, right? I don't know what sort of r value it should be. And if I put in 1, so in conclusion, I can't graph it on decimal. So we just have to believe that our function is on the top. All right, we just have to believe that our function is on top, and we're looking for the area between the function and the x-axis. Okay, so that's embarrassing. Come on, decimals, come on. All right, yeah, but it's my fault. It's not decimals' fault. I'm not trying to blame decimals, but it's just me. I don't know how to configure that. Okay, so we just copied it down. So let's assume this is the top function. Cos 200 pi t over r, right? And minus the what do you call it, the x-axis, right? Integrate with respect to t. All right, so we just leave with this. Because the zero doesn't change anything. I know you might be thinking, why are you writing the same step again? Because I want more communication mark. Full stop. All right. Okay. So we need to start integrating, right? So before we integrate, I want to take the common factor of the no, I'm gonna do something to the equation. All right, I'm not gonna change the value of it. I'm gonna do something. I'm gonna break the fraction apart. It becomes this. Oh, it should be all the way. Right? Yeah, you see what I did? I separated the denominator, all right? Break it into two parts, two fractions, all right? And then I'm going to take the common factor out of it, which would be this. Oh no, it's the whole thing. My bad here. The common factor is actually the whole thing. It's actually this. Right, it's actually 500 over r. Right? Because most of the time, this is what you need to do before you integrate. You're trying to take things out. You're trying to factorize thing, make it into multiply. So what you can do, because right now what we can do, because the relationship here is a multiplication. All right. If you can't see properly, I'll make it more obvious. Multiply this. Right. So we can take this bit outside of the integral sign. Right? Once you made it into a multiplication, you can take things out. Right? But look, if you can still leave it in there. You can still do it as this form. This is still okay. Okay? It just makes some of the number, when you calculate things, it's make it more annoying and long. But look, if you are not confident in factorizing, leave it like that. Okay? But I would encourage you to try to factorize as much as possible. All right, all right, so what we left in the bracket is just this. 1 minus, I will take away the brackets. 1 minus cos 200 pi t. Integrate with respect to t. All right, and now that should be easy. So it would be 507,800 over r is equal to, integrate this. Let's integrate. So integrate 1 with respect to t is giving us t. And then multiply, so minus. Integrating cos give us give us sign. Not negative, but just pure positive sign. 200 pi t. Now the bracket inside doesn't change, but we have to divide it by the derivative of the brackets, which will be 200 pi. Cool. From 0 to 1. Right? All right. Let's expand that big bit. Well, doing what we usually do with definite integral. We sub the 1 into as t, and then we minus and then we sub the t as 0 into the t. Okay, so 1 minus sine 200 pi multiplied by 1 over 200 pi minus 0 minus sine bracket 200 pi times 0 over 200 pi. All right, let's see what happens inside the brackets. All right, so 200 pi times 1 is 200 pi, right? And we know that sine pi is 0. Right, sine pi is 0. If you don't remember, we can choose this particular diagram. So this is pi, and sine it here is 0. Yeah, that's 1. That's negative 1. Yeah, so sine pi is 0. And when we do this 200 times, giving us 200 pi, sine will still be 0. So this whole thing is 0. So it's 1 minus, 1 minus 0. Okay? Minus, I should put it in the brackets in here. Oh, no. We should put a bracket out there just to clarify that. Yeah, love bracket. You have to use brackets to reduce your chances of mistake. So 0 minus, now sine 0 is here, right? And so it's 200 pi times 0 is 0. So sine 0 is 0. It's just 0. So the whole thing is 0. God damn it. Okay, so it's literally just that. So it's literally just 57800 over r multiplied by, because the relationship between them is multiplication. Yeah, just like before. Multiplication. So it's just 1 minus 0 minus 0 minus negative 0. Woohoo! There's still 1. So it's just 57800 over r. What? Right? Because we're looking at the what. Because that's what the question is. Right? The question says that use the result to find find the integral of v squared over r for the period 0 second to 1 second to give an expression for the wattage of the appliance. Right? So what we get should be a watt. Cool, we've done question C. Right? So that we did the integral from 0 second to 1 second and find an expression for the wattage of the appliance. Okay, so that's it. All right, let's go D. Use the result to find the resistance needed for a 1200 watt heating element. Okay, so we got a wattage now. Let's sub that into our previous expression that we got to find the resistance, the ohm, the omega. Such a cool symbol. I like the watches too. Okay, so going D. Right, it's A, B, C, D, right? So this should be D. Yep, should be D. So we know that 57800 over R is equal to a wattage. Right? So we got 57800 over R is equal to 1200 watts. Right? And then let's do some year 1 maths, year 2 maths. Yeah, let's rearrange the equation. Yay! So we go 500 divided by 100 down times 200 equals the R. Right? Did I do it right? Did I do it right? Yeah, pretty sure I did it right. Yeah, cool. All right, let's calculate. That is 57800 divided by 1200. We got 48 and 16 ohm equals to the R. Right? Easy? Cool. Right. So that's it. Okay. Last bit, right? DC powers does not vary over time. Yeah, direct current. What DC voltage, has the same average power as an AC voltage where V0 is equal to 340 volts? Okay. So we're looking for what DC voltage has the same average power as an AC voltage. Right. Okay. Of AC voltage where V0 equal to 340 V. All right. So we're looking at power, right? It has the same power. So we've got our power function somewhere. We've got a power function here. Right? So let's write down something like this. So last one, E. We know that the V squared over R is equal to the power. Right? And this goes for both AC and DC. No, wait, this goes for AC actually. This only goes for AC. Yeah? No, is it? Hold on. Come on. Okay. So the instantaneous generated by resistance R is given by. Okay, so it should be, yeah, it should apply to both. It should apply to both of them, both AC and DC. Right. So let's just assume that V squared over R of the AC is equal to V squared over R of the DC. Right? So, and we also know that the average power, the average watt generated by the AC current is this one. From 0 to 1 second is this particular answer we got here. Right? So that's the power generated. So we know that 57800 over R is equal to this. Right? We take away that. It's just that. 57800 equal to V squared. Right? And with a little bit of square root, we will get 240 volts equal V. And now this, because this V is the DC voltage, right? Because the other side was the AC voltage. So, so that's it. That's the answer, right? Yeah. So I guess the tricky bit here is to get you to understand what the question actually wants you to do, right? So we know that for the instantaneous power, as the question say, let's go back to the question, right? Come on. The instantaneous power generated by a resistance of R omega ohm, is given by that, all right? And this applies to both AC and DC, right? Because AC and DC is just referring to different types of current, right? Alternating current and direct current. But the power formula applies to both of them, right? And in question C, we already got the expression for the wattage, which is the power, for the period from 0 second to 1 second, right? Which is, the question says that since the voltage varies, AC, the power of an appliance is usually stated as the average power over 1 second, right? That is literally the expression for C, the average power over 1 second, right? And so we can come back all the way down here to write out this. So V squared over R is equal to power, both AC and DC. So we put them there, both AC and DC. And we already got the power, the average power of the AC type of voltage over 1 second, right? Which is 57,800 over R. And we just did a little bit of algebra to get V along. And there you go. That V we found at the end will be the DC voltage, right? Equivalent to a V0 of 340 volts AC voltage. Okay? Cool. Now, the question why this is hard is because there's a lot of physics jargon in there. Or, circuit jargon. Circuit and, electric circuit and ohms and everything. All these physics jargons in there. That's what makes it hard. But if you do physics, great. You can understand this a bit more. But if you don't be worried. Just read. Find the keywords in the questions, and you should be able to see. It is very straightforward. If you ask me, is this A level? A minus level, I would suppose. It's not, because we have to use equation that we generated ourselves. So we have to comprehend the questions and get it out and blah blah blah. So yeah, it is an A minus level, I would say. But once you understand it, once you get the hang of it, right? What the hardest bit here would be this identity here. I like it. Interesting. This is the half angle rules. Other than that, very easy. It's just how you understand the question, and what it's asking you. And, practice more and you can get through it. Or listening to this particular video will get you through. All right. Now, I would like to make a shout out, all right, to the student who gave me this question. I believe you can achieve a great result in your Math B, at your final years of Math B. Okay? Don't give up. Try everything. Try as hard as you can. Get to know more questions. Listening to more of my videos, and just let me know if you got any questions and stuff. And of course, we will see each other when we come sit down and stuff. But I believe you got the talent, right? You got the talent, and when I explain to you about this question the first time when I see you, you understand it, so you can do it, right? If you can do this A minus level question, well, you'll be set for the test. You'll be fine. You'll be completely fine, right? So don't give up. Keep learning. All right. Just because your teacher doesn't show you how to do things doesn't mean you can't find out how to do things. Always reach out for help. Seek extra. All right. And if you come across a problem, a difficult, if you're stuck somewhere, reach out for help. Ask me. Ask other people. Go online. Go to YouTube. Go to the World Wide Web. And the answer is just right there, waiting for the people who actually seeks it. Quote the Bible: "Ask and you shall receive. Ask and you shall receive." All right, that's it. Hopefully you guys like this particular video. Hopefully this video helps you to, at least it helps you to deal with one type of question now. So, yep, that's it. I will see you next time.